Pricing a second-story remodel typically involves two primary methods: firstly, per square foot estimation, and secondly, per opening estimation. For the per square foot method, a range of $150 to $250 per square foot, covering both labor and materials, is generally applicable. The per opening method, focusing on doors and windows, usually ranges from $20 to $50 per opening. Several factors should be carefully considered when formulating a cost estimate. The square footage of the new space, encompassing bedrooms, bathrooms, and hallways, is crucial. Accurately measure the total square footage to ensure a precise calculation. The number of windows and doors in the remodeled space also needs to be accounted for. Count each opening to derive an accurate estimate based on the per opening method. Running new electrical circuits upstairs can be a particularly labor-intensive aspect of the remodel. To account for these potential electrical challenges, consider increasing either the per square foot price or the per opening price by approximately 10% to 20%. While the homeowner may have already pulled some of the electrical home runs, it is vital to independently verify the accuracy and completeness of this work. If the circuits have not been properly installed, additional labor costs will be incurred. As a general rule of thumb, for a basic second-story remodel that includes 2 bedrooms and a half bath, a per square foot price ranging from $150 to $250 provides a reasonable starting point. However, this price should be adjusted if there are significant electrical complexities or if the homeowner's previously completed electrical work is incomplete or incorrect. To illustrate this, let's assume a 600 square foot remodel. At $150 per square foot, the initial estimate would be $90,000. If the cost is $250 per square foot, the estimate rises to $150,000. Now, factor in a 15% increase to account for potential electrical issues. Applying this to the lower estimate, $90,000 multiplied by 1.15 equals $103,500. Similarly, for the higher estimate, $150,000 multiplied by 1.15 results in $172,500. When undertaking a remodel, it is also essential to consider several additional points. Firstly, local codes and building permits must be adhered to. Check all relevant regulations to ensure compliance. Secondly, factor in the cost of any specialized materials or finishes required for the remodel. Thirdly, it is wise to obtain multiple quotes from licensed contractors. This ensures that the final price is competitive and fair. Estimating electrical work involves several key steps. Firstly, determining the load calculation. Secondly, selecting the appropriate wire gauge. Thirdly, choosing the right conduit size. Fourthly, calculating voltage drop. And fifthly, estimating labor costs. Firstly, start by determining the total electrical load. This involves adding up the wattage of all the lights, appliances, and equipment that will be connected to the circuit. For lighting, estimate the wattage based on the type and number of fixtures. For appliances and equipment, refer to the nameplates to find their power consumption in watts or amps. Be sure to include an additional capacity for future expansion. Secondly, once you know the total load, you can select the appropriate wire gauge using the National Electrical Code, NEC, Table 310.15. This table provides the allowable ampacities for different wire sizes based on their insulation type and installation method. Ensure that the wire gauge you select can safely handle the calculated load. Also, consider directing factors for ambient temperature and the number of conductors in a raceway. Thirdly, if you are running wires and conduit, you need to choose the right size to accommodate the number and gauge of wires. NEC Chapter 9 Table 4 provides the maximum number of conductors allowed in different conduit sizes. Make sure to leave enough space for easy wire pulling and to avoid overheating. Fourthly, voltage drop is the reduction in voltage that occurs along the wire due to its resistance. Excessive voltage drop can cause appliances to malfunction and lights to dim. To calculate voltage drop, use the formula voltage drop equals 2 times the length of the wire in feet times the current in amps times the resistance per foot divided by 1000. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Lastly, estimating labor costs involves considering the time required to complete the electrical work, the hourly rate of the electrician, and any additional expenses such as travel time and materials. Break down the project into smaller tasks and estimate the time needed for each task. Obtain quotes from several licensed electricians to get a competitive price. When dealing with aluminum wiring, special considerations are necessary to ensure safety and reliability. Aluminum wiring was commonly used in homes built between the 1960s and 1970s, but it has some inherent issues that can lead to fire hazards. Firstly, aluminum expands and contracts more than copper when heated and cooled. This can cause the connections to loosen over time, leading to arcing and overheating. Secondly, aluminum oxidizes when exposed to air, forming a non-conductive layer that can increase resistance of connections. Thirdly, aluminum is softer than copper and more susceptible to damage during installation. If you have aluminum wiring in a home, it is crucial to take steps to mitigate these risks. One option is to replace all the aluminum wiring with copper wiring, which is the safest and most reliable solution. However, this can be expensive and disruptive. A more cost-effective alternative is to use copolymer crimp connectors. These connectors are specifically designed for joining aluminum and copper wires. They create a tight, reliable connection that prevents oxidation and loosening. Another option is to use Alumicon connectors, which are screw-on connectors that are also designed for joining aluminum and copper wires. These connectors are easier to install than copolymer connectors, but they may not be as reliable in the long run. Regardless of which method you choose, it is essential to have a qualified electrician perform the work to ensure that it is done safely and correctly. Also, regularly inspect the connections to check for any signs of loosening or corrosion. When working with different types of electrical boxes, understanding their specific applications is essential for safe and compliant installations. Firstly, plastic boxes, typically made of polyvinyl chloride, PVC, are lightweight, non-conductive, and resistant to corrosion. They are commonly used in residential wiring for switches, outlets, and lighting fixtures. PVC boxes are suitable for dry locations and can be used with non-metallic sheathed cable, such as NMB cable. Secondly, metal boxes, usually made of steel or aluminum, are more durable and can provide better protection for wiring. They are commonly used in commercial and industrial settings, as well as in residential applications where extra protection is needed. Metal boxes must be grounded to prevent electrical shock hazards. Thirdly, countable boxes are designed to be joined together to create larger boxes for multiple switches or outlets. They are available in both plastic and metal versions. Countable boxes are useful for situations where you need to install several devices in a single location. Fourthly, weatherproof boxes are designed to protect wiring from the elements. They are typically used outdoors for lighting fixtures, receptacles, and other electrical devices. Weatherproof boxes have a gasketed cover that seals tightly to prevent water from entering. Fifthly, ceiling fan boxes are specifically designed to support the weight and vibration of ceiling fans. They are typically made of metal and are securely mounted to the ceiling joists. Ceiling fan boxes are essential for safely installing ceiling fans. When selecting an electrical box, consider the following factors. Firstly, the location of the box. Secondly, the number and size of wires that will be entering the box. Thirdly, the type of wiring method being used. And fourthly, any applicable codes and regulations. Always choose a box that is appropriate for the intended application and that meets all safety requirements. When installing a subpanel, several key considerations must be addressed to ensure a safe and compliant installation. Firstly, location is a crucial factor. The subpanel should be installed in a dry, accessible location that is close to the load it will be serving. Avoid installing subpanels in damp or hazardous areas. Secondly, size matters when it comes to subpanels. The size of the subpanel should be determined by the total load it will be serving, as well as any future expansion plans. Choose a subpanel with enough circuit breakers to accommodate all the circuits you need. Thirdly, the feeder size. The wires that supply power to the subpanel must be properly sized to handle the load. Use the NEC table 310.15 to determine the appropriate wire gauge based on the ampacity of the circuit breaker protecting the feeder. Fourthly, grounding is essential for safety. The subpanel must be properly grounded to the main electrical panel. This involves connecting a grounding electrode conductor from the subpanel to a grounding electrode, such as a ground rod or a metal water pipe. Fifthly, bonding is another important safety consideration. The metal enclosure of the subpanel must be bonded to the grounding system. This helps to prevent electrical shock hazards. Sixthly, circuit breakers protect the circuits in the subpanel from overloads and short circuits. Choose circuit breakers with the correct ampacity for each circuit. Seventhly, labeling is crucial for identifying the circuits in the subpanel. Clearly label each circuit breaker with the corresponding load it serves. Eighthly, permits and inspections may be required for installing a subpanel. Check with your local building department to determine the requirements in your area. Ninthly, safety precautions should always be followed when working with electricity. Turn off the power to the main electrical panel before starting any work. Wear appropriate personal protective equipment, such as gloves and safety glasses. Lastly, professional installation is recommended for installing a subpanel. A qualified electrician can ensure that the installation is done safely and correctly. When dealing with 120 volts versus 240 volt circuits, it is essential to understand the differences and applications of each voltage level. Firstly, 120 volt circuits are commonly used in residential wiring for lighting, receptacles and small appliances. They are typically supplied by a single-phase, 3-wire system, with a neutral wire and 2 hot wires that are 120 volts out of phase with each other. Secondly, 240 volt circuits are used for larger appliances, such as electric ranges, dryers and air conditioners. They are typically supplied by a single-phase, 3-wire system, with 2 hot wires that are 240 volts out of phase with each other. The neutral wire is not always required for 240 volt circuits. Thirdly, the main difference between 120 volts and 240 volt circuits is the amount of power they can deliver. 240 volt circuits can deliver twice the power of 120 volt circuits, which is why they are used for high power appliances. Fourthly, 120 volt circuits are generally safer than 240 volt circuits because they deliver less voltage. However, both voltage levels can be dangerous if not handled properly. Fifthly, 120 volt circuits typically use 15 amps or 20 amp circuit breakers, while 240 volt circuits typically use 30 amps, 40 amps or 50 amp circuit breakers. Sixthly, the wiring for 120 volt circuits is typically 14 American wire gauge AWG or 12 AWG, while the wiring for 240 volt circuits is typically 10 AWG, 8 AWG or 6 AWG, depending on the ampacity of the circuit breaker. Seventhly, 120 volts receptacles have 2 slots, one for the hot wire and one for the neutral wire, while 240 volts receptacles have 3 or 4 slots depending on whether a neutral wire is required. Eighthly, when installing 240 volt circuits, it is important to use the correct type of receptacle and circuit breaker. Also, make sure to follow all applicable codes and regulations. Lastly, if you are not comfortable working with electricity, it is best to hire a qualified electrician to install or repair electrical circuits. When working with FSI and GFCI breakers, it is crucial to understand their functions and applications to ensure electrical safety. Firstly, an arc fault circuit interrupter, FSI breaker, is designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps from one conductor to another, creating heat and sparks. FSI breakers detect these arc faults and quickly shut off the power to the circuit. Secondly, FSI breakers are typically required in bedrooms, living rooms and other areas where arc faults are more likely to occur. The NEC specifies where FSI protection is required. Thirdly, a ground fault circuit interrupter, GFCI, breaker is designed to protect against ground faults, which occur when electricity leaks to ground. Ground faults can cause electrical shock hazards. GFCI breakers detect these ground faults and quickly shut off the power to the circuit. Fourthly, GFCI breakers are typically required in bathrooms, kitchens, garages, and other areas where water is present. The NEC specifies where GFCI protection is required. Fifthly, FCI breakers and GFCI breakers are different types of circuit breakers that protect against different types of electrical hazards. FCI breakers protect against arc faults, while GFCI breakers protect against ground faults. Sixthly, FCI breakers and GFCI breakers can be used together on the same circuit to provide comprehensive protection against both arc faults and ground faults. Seventhly, when installing FCI breakers and GFCI breakers, it is important to follow the manufacturer's instructions carefully. Also, make sure to test the breakers regularly to ensure that they are working properly. Eighthly, FCI breakers and GFCI breakers can sometimes trip nuisance trips, which are unexpected and unwanted trips. This can be caused by various factors such as loose wiring, faulty appliances, or electrical noise. Lastly, if you are experiencing frequent nuisance trips with your FCI breakers or GFCI breakers, it is best to consult with a qualified electrician to diagnose and resolve the problem. When dealing with knob and tube wiring, it is essential to understand its characteristics and potential hazards. Knob and tube wiring is an outdated wiring method that was commonly used in homes built before the 1940s. Firstly, knob and tube wiring consists of single insulated wires that are run through ceramic knobs and tubes. The knobs support the wires, while the tubes protect the wires as they pass through walls and ceilings. Secondly, knob and tube wiring typically does not have a grounding conductor, which can increase the risk of electrical shock hazards. Thirdly, the insulation on knob and tube wiring can deteriorate over time, becoming brittle and cracked. This can expose the bare wires and create a fire hazard. Fourthly, knob and tube wiring is not designed to handle the electrical loads of modern appliances. Overloading knob and tube wiring can cause it to overheat and start a fire. Fifthly, many insurance companies will not insure homes with knob and tube wiring unless it is replaced or upgraded. Sixthly, if you have knob and tube wiring in your home, it is recommended to have it inspected by a qualified electrician. The electrician can assess the condition of the wiring and recommend the best course of action. Seventhly, the safest option is to replace the knob and tube wiring with modern wiring, such as non-metallic sheath cable. This will provide a safer and more reliable electrical system. Eighthly, if you choose not to replace the knob and tube wiring, there are some steps you can take to mitigate the risks. These include ensuring that the wiring is not overloaded, replacing any damaged insulation, and adding GFCI protection to circuits that serve wet areas. Lastly, never attempt to work on knob and tube wiring yourself. It is a dangerous task that should only be performed by a qualified electrician. When dealing with electrical permits and inspections, it is crucial to understand the requirements and procedures to ensure compliance with electrical codes and regulations. Firstly, an electrical permit is a document that authorizes you to perform electrical work. Permits are typically required for new installations, alterations, and repairs to electrical systems. Secondly, the purpose of electrical permits is to ensure that electrical work is done safely and correctly. Permits help to prevent electrical fires, shocks, and other hazards. Thirdly, to obtain an electrical permit, you typically need to submit an application to your local building department. The application will require information about the scope of work, the location of the project, and the name of the licensed electrician who will be performing the work. Fourthly, an electrical inspection is a review of the electrical work by a qualified inspector. Inspections are typically required after the electrical work is completed to ensure that it meets the requirements of the electrical code. Fifthly, the purpose of electrical inspections is to verify that the electrical work has been done safely and correctly. Inspections help to identify any potential hazards and ensure that the electrical system is functioning properly. Sixthly, to schedule an electrical inspection, you typically need to contact your local building department. The inspector will come to your property and review the electrical work. Seventhly, if the electrical work passes inspection, the inspector will issue a certificate of compliance. This certificate is proof that the electrical work meets the requirements of the electrical code. Eighthly, if the electrical work fails inspection, the inspector will issue a list of deficiencies that need to be corrected. You will need to correct these deficiencies and schedule another inspection. Ninthly, it is important to obtain all required electrical permits and inspections before starting any electrical work. Failure to do so can result in fines, delays, and other penalties. Lastly, always hire a licensed electrician to perform electrical work. A licensed electrician has the knowledge and experience to perform electrical work safely and correctly. When performing electrical troubleshooting, it is essential to follow a systematic approach to identify and resolve electrical problems. Firstly, start by gathering information about the problem. Ask questions such as what is happening, when did it start, and what have you tried so far. Secondly, identify the circuit that is affected by the problem. Look at the circuit breaker panel and determine which breaker controls the circuit. Thirdly, check the circuit breaker to see if it has tripped. If it has, reset the breaker and see if the problem is resolved. Fourthly, if the circuit breaker has not tripped, check the wiring and connections in the circuit. Look for loose wires, damaged insulation, and corroded connections. Fifthly, use a multimeter to test the voltage, current, and resistance in the circuit. This will help you to identify any electrical problems such as shorts, opens, or ground faults. Sixthly, if you suspect a faulty device, such as a switch, receptacle, or appliance, test it with a multimeter or replace it with a known good device. Seventhly, if you are working on a 240-volt circuit, be sure to turn off both circuit breakers that supply power to the circuit. Eighthly, when troubleshooting electrical problems, always follow safety precautions. Wear appropriate personal protective equipment, such as gloves and safety glasses. Ninthly, if you are not comfortable working with electricity, it is best to hire a qualified electrician to troubleshoot the problem. Lastly, after you have resolved the electrical problem, test the circuit to make sure that it is working properly. In summary, accurately estimating the cost of a second-story remodel involves a careful assessment of square footage, openings, potential electrical challenges, and verification of any existing work. Adhering to safety measures is paramount.